this video you are going to learn about the molarity, but before understanding molarity we will study about the solution. A solution is a homogeneous mixture of solute and solvent. A solution is a homogeneous mixture of solute and solvent. Homogeneous mixture of solute and solvent means the solute is uniformly distributed in the entire body of the solvent. Homogeneous mixture of solute and solvent means the solute is uniformly distributed in the entire body of the solvent. Okay. Then next you may ask, what is a solute and solvent? A solute is a substance which dissolves in some other substance. Okay. A solute is a substance which dissolves in some other substance, and some other substance in which the solute dissolves is the solvent. Okay. If you dissolve the sodium chloride in water, then a solution of sodium chloride is formed. Okay. Now in this sodium chloride solution, sodium chloride is the solute and water is the solvent. Okay. Now here sodium chloride dissolves in water. So sodium chloride is the solute and water is the solvent. Okay. The solute means the substance which dissolves in some other substance, and some other substance in which the solute dissolves is nothing but the solvent. Okay. If you simply say sodium chloride solution, then you will not know how much of sodium chloride is dissolved in how much of the water, or how much of sodium chloride is present in how much solution. Okay. So in this solution, sodium chloride is solute and water is the solvent. Okay. So if you want to know how much sodium chloride is dissolved in how much water, then we have to use the term concentration. Okay. So concentration of solution gives the strength of the solution, and it indicates how much quantity of the solute is present in how much volume of the solution. Okay. So if you know the quantity of the solute and the quantity of the solution, then we say that it is the concentration of the solution. Okay. So concentration of solution gives strength of the solution, and it indicates how much quantity or how many moles of solute is present in how much volume or how much quantity of the solution. Okay. So molarity is the term used to express the concentration of the solution. Molarity is the term used to express concentration of the solution. Now we define the term molarity. Molarity of a solution is defined as the number of moles of solute present in 1 liter of the solution. Okay. It is defined as the number of moles of solute present in 1 liter of the solution. Okay. So whatever may be the number of moles present in 1 liter of solution, that number of moles of the solute is nothing but the molarity, and this molarity is denoted as capital M, and it is expressed as mole per liter. That means the unit of molarity is mole per liter. Okay. So this unit itself indicates that the number of moles of the solute are present in only 1 liter. Okay. The number of moles present in 1 liter is nothing but the molarity of the solution. Okay. If 1 mole of solute is present in 1 liter of solution, then concentration of solution is said to be of 1 molarity. Okay, dear friends, it is very simple concept. Whatever the number of moles of the solute are present in 1 liter of the solution, that itself is nothing but molarity of the solution. If 1 mole of solute is present in 1 liter of solution, then the concentration of solution is said to be 1 molarity, and it is denoted as 1m. Okay. And this solution is called 1 molar solution. So 1 molar solution is the solution of molarity 1. Okay. 1 molar solution is the solution of molarity 1. That means 1 mole of the solute is present in 1 liter of the solution. Okay. Suppose 2 moles of solute are present in 1 liter. then the concentration of solution is said to be 2 molarity and it is denoted as 2m. Okay, so if 1 mole of solute is present in 1 liter, then concentration of solution is 1 molarity. If 2 moles of solute are present in 1 liter of solution, then the concentration of solution is 2 molarity. Okay, likewise you may have solutions of concentration 3 molarity, 4 molarity and so on. Okay, so 3 molarity means 3 moles of the solute are present in 1 liter. Okay, so 4 molarity means 4 moles of solute are present in 1 liter. Okay, so suppose 1/10 of 1 mole of solute is present in 1 liter. That is 1/10 of 1 mole means that is 0.1 mole. Okay, if 0.1 mole of solute is present in 1 liter, then concentration of solution is said to be 0.1 m. Okay, so molarity of solution is 0.1 m, and this solution is now called the decimolar solution. Okay, so decimolar solution is a solution of molarity 0.1 m. Okay, and molar solution is nothing but solution of molarity 1. Okay, consider 1m HCl solution. Now this 1m HCl solution contains 1 mole of HCl, that is 36.45 gram of HCl present in 1 liter of solution. Okay, now this 36.45 gram is nothing but the molar mass of HCl. So 1m HCl contains 36.45 gram of HCl present in 1 liter of the solution. Okay, now if you consider 2m HCl solution, okay, now 2m HCl solution contains 2 moles of HCl, that is a 2 into 36.45 gram, that is a 72.90 gram of HCl present in 1 liter of the solution. Okay, now similarly if you consider 0.1 mHCl, now this 0.1 mHCl contains 1/10 of 1 mole of HCl, that is 1/10 of 36.45 gram, that is nothing but 3.65 gram of HCl that is present in 1 liter of the solution. Okay, now these concentrations indicate the quantity of the solute as well as the quantity of the solution. Okay, so if it is a 1m solution, it will be containing 1 mole of solute in 1 liter of the solution. Similarly, 2m solution contains the 2 moles of the solute present in 1 liter of the solution. If it is a 0.1 m solution, it will be containing 0.1 mole of the solute present in 1 liter of solution. Now here in each of these, the volume of the solution is 1 liter, but the number of moles are different. Okay, so whatever the number of moles of the solute are present in 1 liter of solution, that is nothing but the molarity of the solution. Okay, now let us see the formula to calculate the molarity of the solution. So molarity of the solution is calculated by using the formula molarity capital M equal to a number of moles of the solute small n divided by volume of the solution in liter, that is capital V, that is equal to n divided by V. So this is the formula to calculate the molarity of the solution if the number of moles of solute and volume of solution are given. Okay, so molarity M equal to n divided by V. Okay, and dear friends, you have already studied in the previous video that number of moles n can be calculated by using this formula, given mass in gram divided by molar mass. Okay, so given mass in gram is small m and molar mass is capital M, so small m divided by capital M will give the number of moles, that is small n. So if you substitute the value of n in the formula for the molarity, then we can also write the molarity as m equal to small m divided by capital M into V. Okay, now in this formula, small m is the given mass of the solute in gram and capital M is molar mass of the solute and capital V is the volume of solution in liter. Okay, So there are two formula to calculate the molarity of the solution. The first formula is N divided by V. So where N is the number of moles of solute and V is the volume of solution in liter. Okay. Then second formula is small m divided by capital M into capital V. Okay. So depending upon the given quantities, we can use any one of these formula. Okay. So remember these two formula. First formula is N divided by V, where N is the number of moles of solute and V is the volume of the solution in liter. Second formula is small m divided by capital M into capital V. So here small m is the given mass of the solute in gram, capital M is the molar mass of solute, and V is the volume of solution in liter. Okay. Suppose the volume of solution is given in milliliter, so that should be converted into a liter by dividing with 1000. Okay, so if we divide the volume of solution in ml with 1000, we will get the volume of solution in liter. Okay, now based on this formula, let us work out some problems. Find the molarity of the solution containing 4 gram of the sodium hydroxide and 500 ml. Okay, now in this problem it is given that mass of sodium hydroxide solution small m is equal to 4 gram. Then molar mass of sodium hydroxide, that is NaOH, is equal to 23 plus 16 plus 1, that is equal to 40 gram per mole. Now this is obtained by adding the gram atomic mass of sodium, oxygen and hydrogen present in 1 molecule of sodium hydroxide. You know that gram atomic mass of sodium is a 23 gram, gram atomic mass of oxygen is 16 gram and gram atomic mass of hydrogen is 1 gram. So if you add all this, you will get 40 gram per mole, that is the molar mass of the sodium hydroxide. Okay, and volume of solution V is given to be equal to 500 ml. Now this should be converted to liter by dividing this 500 ml with 1000. Okay, so 500 ml divided by 1000 will give 0.5 liter. Okay, and we know that the molarity capital M is equal to small m divided by capital M into capital V. So here the mass of sodium hydroxide small m is going to be 4 gram. Molar mass of the sodium hydroxide that we have calculated, that is equal to 40 gram per mole, and volume is going to be 0.5 liter. If we substitute all these, we will get 4 divided by 40 into 0.5, that is equal to 0.2 m. Okay, dear friends, so the molarity of solution containing 4 gram of sodium hydroxide solution in 500 ml is equal to 0.2 m. Okay, so in this way we have to calculate the molarity of the solution when the mass of the solute is given and volume of the solution is given. Okay, next we shall consider this problem. Find the mass of sodium chloride required to prepare 250 ml of 0.1 m solution. Dear friends, in this problem they have given the molarity of the sodium chloride solution, that is equal to 0.1 m, and then volume of solution V equal to 250 ml, that is converted into liter by dividing with 1000. So 250 ml divided by 1000 will give 0.250 liter, and then we have to find the molar mass of sodium chloride, that is NaCl. So that will be equal to 23 plus 35.45, that is equal to 58.45 gram per mole. So here 23 gram is a gram atomic mass of sodium and 35.45 gram is the gram atomic mass of chlorine. If we add these two, you will get 58.45 gram per mole, that is a molar mass of the sodium chloride. Okay, now here we know that the molarity M is equal to small m divided by capital M into capital V. Now in this formula, small m is the mass of the solute and capital M in the denominator is the molar mass of the solute, and capital V is a volume of solution in liter. So here we have to find out the mass of the sodium chloride. So therefore we have to multiply molarity, molar mass and volume of the solution. Okay, so here the mass of sodium chloride required to prepare 250 ml of 0.1 m solution, small m is equal to molarity into molar mass into volume in liter. So that will be equal to 0.1 mole per liter into 58.45 gram per mole into 0.250 liter. So this will be equal to 1.46 gram. Okay, so dear friends, so 1.46 gram is the mass of sodium chloride required to prepare 250 ml of 0.1 m solution. Okay, I hope you have followed how to find out the mass of the solute when the molarity of the solution and volume of solution are given. Similarly, you can also find out the molarity of solution when the number of moles and volume of solution is given. Okay, so I hope you have understood. So wish you all the best. And if you want to have the clear understanding of mole concept and molar volume, you can watch the previous videos that I have released. Okay, thank you once again. Wish you all the best.